So, Lara, okay, let's start. Let's start talking about how to stay on top of Java news from 8 to 21. I'm Thiago Bomfim, and I hope I can show you something new here. So we are going to 4 things. We start talking about how to increase development productivity. Then we'll talk about performance and garbage collector. Then we'll talk about framework and the future. And last but not least, how to stay up to date with the news. So let's start talking about how to increase development productivity. But before talking about the new things, let's get a step back and talk about some important things. So let's understand what means LTS version. LTS means long-term support. And this means that the vendors keep these versions updated for long time. As you can see here, Java 21 was released this year on September 2023, and the extended support will be until September 2031. Oracle usually has 8 years of extended support, and of course there are other vendors like Amazon and Microsoft and others. So it's very important to be aware of it and to use LTS versions in your code in production, okay? Because otherwise, if you're not using LTS version, you do not have support, and this version can have some problem, vulnerability, bug, and you do not have support for that. So we are going to talk a lot about Java 8, Java 11, 17, and 21, because these are the versions, the LTS versions that we have now. Okay, great. Another important thing to be aware, it's about JEP. What is JEP? JEP is JDK Enhancement Proposal, and this is a document whose proposal is to add new things on Java, okay? Usually, big things are done by JEPs, and not just bring new things, also remove things, okay? So if something will be removed, usually are done by JEPs, if the thing is big thing, okay? Great. So now let's start. Let's start easy. Let's start seeing a string, because I think most of us are familiar with that. So let's say that you have a method to write a poem, and in the end, you have the concatenation with the author. I think everyone understand this code. This is code. We have just a string, a lot of concatenation. Okay, this works on Java 8, 11, 21. Okay, we have that in Java 8. We can also use string builder, okay? It's still this kind of same thing. We have a lot of append. It don't get really much better. So I ask you, can we improve it? And the answer is yes. If you're using Java 17, we have text blocks that was released on Java 15. And now we can use that. And now it's much easier if you want to copy and paste this poem in some place, and now it's much easier also to read. We do not have a lot of concatenations, but we still have the concatenation with the author. So I ask you again, can we improve it? And the answer is yes. If you're using Java 21, we can use string templates. And now we have something like that. On the end, as you can see, we have the slash and the author, and yeah, this works, and now it's much better. But you can think, yeah, it's okay, I guess. Maybe I don't bring the best example. So let's see it again. Let's bring a JSON, because I think most of us are familiar with JSON. So we have here a Pokemon, a JSON for a Pokemon. Let's see again our examples. So if you are using Java 8 or 11, you have something like that. Yeah, not really good, right? Not easy to read. And we have a lot of chances of bugs here. Maybe to forget a comma or change something here. I don't know. We have many chances of bugs here. We can also use string builder, but yeah, in my opinion, I think it gets worse. At least if you want to read it, not really good. And then I ask you, can you improve it? And I hope you answer yes, because I show you. We can use text blocks. And with text blocks, now it's much easier to read, to copy and paste. But as you can see here, we have this %s. And yeah, this is maybe not the best thing, right? Because if you flip the ID and the name, if you change them, we have a bug. And maybe you just realize that in a test environment or in production, and this is really bad, right? So I ask you again, can we improve it? And I hope you answer yes. We can now use string templates that was available on Java 21. But be aware that this is a preview feature. What this means? This means that this feature can have chains in the future and also break chains. So if you want to use it, it works. No problem with it. It's work, but you can maybe have break chains in the future. I don't think so for string templates, but it can happen. Okay, so now we have this solution, but you can maybe you will look for it and think, oh, this is a chaos. It's a mess. I don't like it. It like JSP, many things, not really easy to understand. But I promise you, if you're using the latest version of your IDE, probably IntelliJ, you have different colors, and this will be much easier to read. And if you don't believe me, here are the code. So now it's much easier to read, to understand, and to use it. And of course, few chance of bugs. Amazing. Okay, job well done. Great, let's move on. Let's talk about instance of. But before talking about instance of, if you have any doubt, we'll have some times on the end, but you can also ask on the chat, okay? So, okay, moving on, let's talk about instance of. Here we have three animals. We have the animal that it's an abstract class, and then we have the toucan and also the lion. Toucan know how to get food and how to fly, and lion know how to hunt, how to climb a tree, and get food. Okay, great. So let's say that you want to create a method that receives an animal, and then we return the food. We can do animal instance of toucan, and then we need to cast and then get the food. The same for lion. If you are using Java 8 or 11, you have something like that. And then I ask you, can you improve it? And the answer is yes. If you are using Java 17, we can use pattern matching for instance of. And now we can declare the variable in the if statement. And we do not need to cast it anymore. Great, amazing. But why not ask you again, can we improve it? And the answer is yes. Now in Java 21, we have pattern matching for switch, and now we can do something like that. And as you can see here, we do also have this case null that will help us to avoid null pointer exception. Amazing. Few chance of bugs and a much easier code to read, much cleaner. Amazing. So as you can see on the right, on the left, we have the solution that you will probably have on Java 8 or 11, and on the right, the solution that you can have on Java 21. Amazing. But why not? I ask you again, can you improve it? What do you think? Please put on the chat, what do you think? There is anything here that I'm I'm missing that I don't know, maybe you know. Can you improve it? Can you improve it? Feel free to put on the chat if you think that we can or not improve it. Okay? I will show it in a minute. Okay, so as I said, on the right, we have the solution that you can have on Java 21, in the left, Java 8. But there is a better solution, okay, for both cases. We can use polymorphism. This is the base, okay? This is OOP. We can just do that. Animal.getFood, and it's done. Just one line, very easy. We do not need to use pattern matching, for instance, of just that. This is the base, okay? This is very important. So then you can ask me, oh, so what is the proposal for pattern matching, for instance, of if you have polymorphism? Why do you have that? Well, let's get back to our example. So we have the animal, the toucan, and the lion. As you can see, toucan know how to fly, and lion know how to hunt and how to climb tree. This is different actions. So in this case, we cannot use polymorphism. So let's go to our solution. So if you have a method called, for example, do action, in this case, we need this instance of, and in this case, if you're using Java 8, we need to cast and do something like that. And then I ask you, can we improve it? And I hope the answer is yes, because I have shown you before. We can use pattern matching, for instance, of if you're using Java 17. And now you do not need to cast it anymore. You can declare the variable in the if statement. Amazing. And if I ask you again, can you improve it? I hope you answer yes, because we can using pattern matching for switch that was available on Java 21. Amazing. This will work. It's great. We do not need to cast, include the instance of, same code, fewer chance of bugs, easy to read. Amazing. Good job. But why not? Ask, can you improve it? Let's go, let's go. Time to improve. Challenge accepted. Let's improve it. So we have that, right? We have the animal, the toucan, and the lion. Okay, this works fine. But if you are using Java 17, we can use sealed class, okay? Sealed class provide more control over the inheritance. So as you can see here, the animal is an abstract class, and it's a sealed class, and it permits toucan and lion. And as you can see here, toucan and lion both are final. And why that? Because all sealed class must be final, sealed, or unsealed class. Final means that no one can inheritance for it from this class, and sealed, as you can see, it's sealed class, and then you have the control over the inheritance. Okay, amazing. We have that on Java 17. And how about our code? Well, nothing changed, same code. But let's do something else. Let's add a new animal. So now we create a new animal, shark. We permit the shark, and shark knows how to swim. And now what happens? Well, now we have a compilation error, and this is amazing because who has never experienced this before? Forgetting to implement a new use case on a switch because we did not know about that. We did not receive any type of alert. So now we have compilation error, and this is amazing. Fewer chance of bugs. Great. But be careful, okay? Because in this case, we do not have default. If you have default, case, we do not have the completion error. So be careful. We should not use default in this case. So if you are using sealed class or enum, maybe using the default, it's not the best case, okay? It's not the best approach. So yeah, in this case, we do not have default, and we do not want to have default in this case. So we have completion error. Amazing. Job well done. Okay, let's get back to the past. Let's go to our first example. So we have that JSON for a Pokemon. And how about this class? Well, if you're using Java 8 or 11, you probably have something like that. Let's say that you want to create a mutable class or something like that. We have a final class, final attributes, and getters. And okay, this works. Great. And then I ask you, can you improve it? And I hope you answer yes, because I hope you already know that. But if you don't know, in Java 17, we have records. And records are kind of immutable data. So we just have getters. We do not have setters. And records, it's kind of compact syntax for declaring the class. So it's short and much easier to read. And again, it follows the immutable pattern. So yeah, it's very good to use it because of the immutable pattern. And not just that, if you are using record, just because you are using record, because they are trust final fields in record done by this JTK, you have some performance improvements, okay? In some use case, of course. So just because of that, just because you are using record, you can have some improvements. Can you have fewer line of code and also improvement in performance? Amazing. And now you can ask me, can we use record for pattern matching? Well, let's see. Yes, in Java 21, we have record patterns. And now we can do that. Instance of record, and then we declare the variable in the if statement. Amazing. But why not? Can we improve it? And the answer is yes. Using the record patterns, we can do something like that. We can extract the variables from our record and just use it. So in this case, we are using just one single line to do that. Amazing. And now, maybe you can ask me, can we have record inside record? Let's see. So now we have two records, okay? We have the Pokemon record and the Pokeball. The Pokeball contains a Pokemon. Okay, great. So let's see. If you are using Java 8 or 11, you probably have something like that. Object, instance of, Pokeball, then we have the cast, and then we get the data. And well, what happens if our Pokeball is empty? Well, you probably know this is not a very good case. You have a null pointer exception. Not really good, right? If you're using Java 8 or 11, you have something like that. And this is very hard to identify which object is null, which data is null. If you are violating the law of the meter, this makes things much harder to identify. And if you're using Java 17, we have these helpful null pointer exceptions that was available on Java 14. And now we have something like that. And this is much easier to identify null pointer exceptions. Okay? Amazing. So let's fix it. So if you're using Java 8 or 11, we have something like that. Right? Okay, Great. We have the if statement, the instance of, the cast, many things. And how about now in Java 21? Using record patterns, we can do something like that. Okay, maybe better because you just have one if statement, one line. But if you are like me, I do not like this so much because it's kind of a mess. It's not very easy to read. So I ask you again, can we improve it? And the answer is yes, we can use var, local variable type inference, that was available on Java 10. I will not explain var because again, it was available on Java 10, so I hope you already know var. And using var, we make things smaller, easy to read. Okay, great. But why not ask again? Can we improve it? And the answer is yes. We can use named patterns and variables. This is a preview feature in Java 21. And now we can use just underscore and just that. So if you do not need the data, we just use underscore. And now if you compare both solutions, we'll see something like that. So in the first case is the solution. If you're using Java 8, 11, not really good, right? We have two if statement, we have cast, many things. And now just one if statement, much easier to read and to use. Amazing. Job well done. And because we are talking about unnamed patterns, why not bring our main method? Can we improve it? What do you think? Because we are really familiar with these, right? Public stat void main. Everyone use that. Who thought that we can improve it? But the answer is yes. Now in Java 21, we can improve it. We can use the unnamed class and instance main methods. And now just that works, just void main. And why this is amazing? Because now it's much easier for beginners to learn Java. Okay, it's really hard to start learning Java and need to learn and understand the access modifiers, static, string, array, things like that. So now it's much easier to create a hello world in Java. Amazing. And most of these features that I show you now until now, they are provided by Project Ember, and the goal of Project Ember is to explore and incubate smaller, productivity-oriented Java language feature. So, just recapping, we saw pattern matching for switch, pattern matching for instance of, switch expressions, local variable type inference var, records, sealed class, string templates, text blocks, unnamed class and instance main methods, and also unnamed patterns and variable. Amazing. On the end of this session, okay, I will share the slides and also some links where you can search more and read more details about it. Okay. Let's move on. Now we are going to talk about performance and garbage collector. So let's start talking about garbage collector because we use it every day. So it's very important to know at least a little bit about it. So let's start with a small quiz. How many GC exists? What do you think? Please put on the chat. What do you think? 2, 3, 4, 5, more than 5? Do you have more than one? What do you think? Okay, 2 letter E. Amazing. Okay, many letters E. Anyone think another? Anyone has another thought about that? Okay, let's see the answer. The answer is letter E. So congrats, you are correct. We have more than 5. I will not go into details of all of them. Okay, I'll just explain a little bit about them because we do not have time to go deep on the details about garbage collectors. So let's see just short brief on them. So okay, so the garbage collectors that we have, they are Epsilon, Shenandoah, ZGC, G1, Parallel, CMS, and Serial. And this is just GCs from OpenJDK. So let's see. Parallel GC is the default until Java 8, until Java 9, sorry. So if you're using Java 8, you are probably using Parallel GC, and it is more focused on throughput. We do also have CMS, but you should not use CMS because it was replaced by G1GC, and it was removed by the JAB 363 that was removed after Java 14. Okay, and let's talk about G1GC is the default since Java 9, and it became the default by JAB 248. And it became the default because it more focused on the balance between throughput and latency. It's still the default, okay? And G1 continues to be improved. The next release of Java 22, will have a new improvement on G1, that it's the region fix for G1, that will improve the latency from this GC. We do also have other small improvements like this JTK, that is the configurable card table card size, available on Java 18. We do also have Epsilon. Epsilon is a no-op GC. This means that there is no latency because there is no GC execution. So be careful if you want to use it, because if you have long applications running with Epsilon, you have out of memory error. It was available on Java 11 as experimental. Okay. We do also have Shenandoah, that is a low latency GC. It was available on Java 15 for production. So if you're using Java 17, you have, at least for now, one more choice of GCs. This is a low latency GC. And we do also have ZGC, that is also a low latency GC. They have different reasons, goals, okay, but both are low latency GCs, and both are available on Java 15 for production, so you can use it if you are using Java 17. And now on Java 21, we have a huge improvement on ZGC, that is the generation ZGC. Most of GC's garbage collectors contains different versions. So the generation, the old generation and the young generation, and now ZGC do also have that. Amazing. Okay, let's now go to performance review time. Brace yourself, benchmarks are coming. So let's see a little bit about G1 memory usage. So if you're using Java 8, the same application here for 8, 11, 17, and 18, we can see a huge difference between them. If you're using Java 8, it's kind of 6 to 5 giga. And if you're using Java 18, it's 1.5 giga. And these are really huge improvement in memory usage. If you think about throughput, we can also see that all GCs has been improving the throughput in all of GCs. So if you are using Java 8 and change to Java 17, you have an improvement in the throughput, and not just throughput, but also latency. Okay, so as you can see here, all GCs are improving the latency, and also throughput. And this is amazing. So if you just change Java 8 to Java 17, you have some performance improvements. Okay, great. And because we are talking about Java 21, we need to talk about virtual threads, right? So benchmarks everywhere. Let's see a lot of benchmarks. Kidding, okay? I'm kidding. I will not do that. Let's go to a more fun way. Demo time, because what could possibly go wrong, right? So let me share my code, my screen. Can you see my screen, the IntelliJ? It's okay. Okay, thank you, Gabriel. Okay, so what you have here, okay? We have here two applications, okay? This demo is used in Java 17, and this one is used in Java 21 with Loom, okay? As you can see here, we have two endpoints, a simple one with a thread sleep, and another one that we'll call the sleep 4 times, okay? This happen, it's the same code, okay, for both. Okay, and what we are going to do, I will start all the applications, okay, using Docker Compose, and we are using K6 to test both applications, okay? So we start with just 100 requests, and then we increase it, okay? So both, as you can see, for Loom and for project without Loom. Just to be aware, Loom, it's virtual threads, okay? So when I talk about Loom, it's virtual threads. So this one is virtual threads, this one will not use. Okay, great. So let me run this command just to check if it's everything running. Okay, everything running, fine. Okay, so let's start. Let's start with Project Loom. Okay, so basically here we are requesting calling the endpoint many times. Okay, we have 100 requests per second, and now we just need to wait. As you can see here, our application are using just 20% of memory and 30% of CPU. Okay, it's dealing very well with 100 requests. Okay, great. And how about without virtual threads? Let's see. So it's the same, 100. Okay, great. Let's see. So in this case, okay, 10% of memory, kind of the same as with Project Loom. And the CPU, it's kind of the same, 40%, 30%. Yeah, it's dealing very well. It's handled very well our requests. Okay, it's getting close to the end. Okay, great. Let's see in Grafana. So I hope you can see my screen. So as you can see here, Project Loom and without Project Loom, both almost reach 3,000. So both handle other requests. Okay, great. Let's increase the number. So let's change here for maybe 500. Why not? So let's increase it to 500 and let's run. Okay, great. So let's start with Project Loom. Okay, so as you can see here, 500, we have already some errors. Let's see our application. So now with Project Loom, we are reaching close to 100% of CPU and the memory 7%. Okay, so we are using a lot of our CPU and also memory. Okay. Okay, reach to the end. Now let's run without Project Loom, without virtual threads, and let's see the result. Okay, the same. Let's see. So as you can see here, we are reaching close to 30%, very different, right? A big difference between Project Loom and without Project Loom. And also the CPU. We are not reaching 100% of CPU because we are not able to create thousands of threads. Okay, so as you can see here, we are using first memory and CPU. Let's see our Grafana. So let's see our result. So let's refresh here. So as you can see here, with Project Loom, we are able to handle, in this case, more or almost the double of the application without Project Loom, without virtual threads. So as you can see here, using Project Loom, we can increase a lot our throughput. But as I show you here, we increase our throughput, we keep the same latency. So what is the drawback? The drawback is memory consumption. Okay, we will of course have more memory consumption. We need to have more memory. Okay, so it's very important to be aware of it. Let's get back to our slides. Let me see here. Okay, so let's get back to our slides, and I will share also the code. Okay, so if you want to play with it, feel free. I will share the code on the end. So, okay, so just recapping, if you run with 50 requests per second, both are able to handle. So if you have just few requests per second, with and without virtual threads, the result will probably be the same. Okay, nothing changes. If you increase it a little bit, maybe the result will still be the same, because we do not have, we do not need many threads. But if you keep increasing, we will realize that with Project Loom, with virtual threads, we can have a huge improvement. In this case, almost the double. It was able to handle almost the double of the requests. But of course, there is a drawback. There is a drawback, and the drawback is memory consumption. Okay. And what happens if you keep increasing it? Well, if you try with, for example, 1000, we have a worse result, because this is not a dark magic. It's not a silver bullet. Okay. So yeah, if you want to keep increasing, we need to increase our resource or have more replicas or things like that. Just in using Project Loom, it will not make magic. Okay, but as you can see here, we have a huge improvement to handle the requests. But again, be aware, if you are using Project Loom and you want to handle more requests, you use more memory. Okay, this is the drawback. To keep the same latency, increase the throughput, we will use more memory. Okay. Okay, great. Let's move on. Let's talk now about frameworks and the future. So let's start talking about Spring, because I think most of us know Spring, right? So, okay, if you're using Spring, I hope you are using Spring 3.x. And if you're using Spring 3.x, it requires Java 17. If you're not using Spring 3.x, you are probably using 2.x, and 2.x has the end support expired last month, unless you have a commercial support. Okay, if you do not have, yeah, you probably need to update your versions. So if you go to the Spring Initializer, if you want to create a new project, you see something like that. We now just have Java 21 and 17 and just Spring 3.x. Okay, we do not have Spring 2.x anymore. And another good reason why you should keep updated is because Spring 3.2 support virtual threads, and it's very easy to use it. You just need to add this property. Okay, just enable virtual threads, just that. Amazing. And I will give you some more reasons why you should keep updated, why you should update to the new versions. Here is one big reason: CVS, vulnerability. And if you think, oh, this is low, this don't fit in my case, or something like that, I have more reasons. And this is another reason. This is high, and this is another, also high. This is high, and this is really critical because it's authorization bypass. So yeah, this is bad. And this is critical. This is code injection vulnerability. And you do not want that, okay? You do not want someone stealing the data from your service. You do not want hackers in your system. You do not want your boss telling you that you should spend your holiday or your you spent more hours in your work, maybe past the night, updating your application to the newest versions because you have vulnerability. You do not want that. And how can you avoid that? Well, you have two choices. One choice is you wait your boss tell you, or you tell your boss. Okay, it's just choice. In the end, if you do not do that, if your boss don't do that, probably you have some vulnerability, you have some hacker in your system, and then you'll be required to update your application because it's not you telling, it's not your boss telling, it's the CTO telling, it's the market telling, it's the client telling, and you do not want that. Okay, so you need to keep updated. And how about other frameworks? So if you're using Quarks, well, if you're using Quarks 3 or 2, the minimal version, it still works with Java 11, but the default recommendation is to use Java 17. And if you're using the latest version of Quarks, if you're using 3.7, as you can see here, this announcement was done on the end of last month. Now you need to use at least Java 17. And again, you need to keep updated because of vulnerability and many things. So yeah, now you need to use Java 17. And virtual and Quarks already support virtual threads since last year. So yeah, more reasons why you should keep updated. Amazing. And how about the future? Let's talk about new features. But I promise I will not go really deep on that. Okay. So I will just give a little brief on them. So in Java 22, we have more than 10 JAPs. I bring just some of them. So you have foreign function and memory API. As I said before, we will have region pinning for G1. We'll have statements before super, a preview feature. I like that. You have the unnamed variables and patterns, the final release, amazing. You have stream gutters, I also like that. We have the vector API, the 7th incubator, this is good for machine learning, things like that. And we will also have string templates, the second preview. Amazing. And how about the other versions? Well, in the future, we'll probably have primitive types in patterns, instance of, and switch. Probably the generation for Shenandoah, valid class and objects, and much more. So yeah, I know there are many things to know. All these features help us to deliver better software, to deliver software that is easier to read, and it also helps us to deliver software faster because it's easier to create. And not just that, but fewer bugs, and also less chance of vulnerabilities if you keep updated. So now I ask you if you are ready to keep updated. I hope the answer is yes. I hope you are ready to stay up to date. And then you can ask me how to stay up to date with the news. And now I will share you some tips. How can you do that? Well, you can follow the OpenJDK documentation, which contains all the detail from the chapters, from the projects. There are many things here. You can also use this link to search more jobs and also details from the jobs. Again, I will share the links, okay, and also the presentation slides on the end. You do not need to copy anything here. You can also, because not all improvements are done by JAPs, you can also follow the release notes from Oracle, for example. So this link is for Java 21, and here we have many details about many things, not just the JAPs. And last but not least, you can follow my blog, where I'm posting about best practices and also news from Java. Okay, so I wrote some articles about Java 17, 11, 21. If you want to know and to learn more about it, to deep on that, I recommend you to see it. And here are my contacts. If you have any doubt, you can send me on my LinkedIn. This QR code contains the link for the slides, for the code, and also for my blog. So feel free to access all of them. And I hope you have learned something new, or at least one smile. Okay, thank you all. But before we go to the questions, okay, now you have some time for questions, of course. But before we're going